So, hey, Dave, I'm really excited about this awesome end-to-end demo we've got for the TAF 21 crowd here today.
Absolutely. I'm very excited about this next demo, as it's a great example of our hyperconverged analytics approach, which, as you well know, is all about unifying data integration, visual analytics, data science, and streaming analytics into a seamless experience for all personas. And here, as you know, we're trying to analyze data from remote energy production facilities to prevent failures and enhance product output.
Indeed, and we're, as you say, we're using both our data management and analytics products in a single solution. Hey, did you hear the one about the SQL query who walked up to two tables in a bar and asked, can I join you?
That's a good one. Have you heard about the other one? I once saw this on a T-shirt. It said there are two kinds of data scientists. One, those who can extrapolate from incomplete data.
And no two, right? That's exactly right. Look, we're going to start off by looking at some well production data in Spotfire, and then we'll model these data, look at the metadata, the reference data in TIBCO EBX, create some virtualized views in TIBCO DV for analysis, and go from there, right?
Yeah. And then once we have that single view of, let's say, well information, geological data, equipment data, we can then build machine learning models to predict well performance and even store live equipment data to monitor operations and predict failures in real time.
Terrific. So here's the environment we have to work with. On the left, we've got field operations. Each well is a complex bill of materials from production equipment with lots of master data, metadata, reference data, in addition to the production data that's being produced. And then the equipment is instrumented and produces regular data updates into local historians. And we have to surface and manage all of the real-time data along with the other relevant data and to deliver, timely analytics to the operations center on the right. And we're especially interested in getting exceptions where operations are not going according to plan and the equipment is showing signs of malfunction. We want to prevent failures, extend the equipment life, and enhance production and keep the systems running. So let's take a look at the initial production data.
Thanks, Michael. Thanks, Dev. As Michael and Dev said, we're going to look at well surveillance and equipment surveillance on oil wells in the Texas region. I'm a business analyst, and I've received some CSV files, some data exports from a colleague on my team. And I just want to do an initial business overview and initial exploratory data analysis. So here in Spotfire, I see a bunch of CSVs I received from my colleagues, and I'm just going to grab a few of these. I'm going to grab an operator table, the well index, this production history data, and I'm just going to drag and drop these directly into Spotfire. It's going to give me this data preview where I can see a little bit about the data tables that I'm bringing in. I can check these for data type and accuracy. And now I have this flyout for this add data to Spotfire and add data to my analysis. And Spotfire has automatically recommended that I join some of this data together. It's noticed that my production history from 2014 to 2019 is similar to the table from 2008 to 2013 and recommend that I stack those tables together. I also have these other two tables that are separate, but I want to mash those together as well. So I'm going to go ahead and take these and I'm going to add these as columns to my production history data. So now I have some operator data in there. And I'm going to add my well index information there as well. Add this as columns to my production history table. And let's just rename this to production history right here. And I'll hit OK. And Spotfire is going to now automatically bring this in and generate a whole data canvas preview where I get my whole data flow and data pipeline here for me to see. I can look at each individual table. I can see this production history information with the well ID. This is time series information for a few years, 2014 and 2019. And that's been stacked with this other set of data. And this is showing some different years as well. So you can see 2008 to 2013 here. And this is being added as rows. And I have operator data. These are information about the different operators that are working on each well, and the latitude and longitude and other information about those wells. That's all being joined in, and I'm getting this nice little preview. So I finally get this big table all put together, and in Spotfire I can open up my data panel here, and I can look at oil. If I want to see what is predicting oil, I can get recommendations, I can create different charts. So if I want to do a quick thing of oil, latitude and longitude, this will show me all my different wells by clicking the create map chart. And now I can see oil produced at all these different locations. And if I want to see this over time, why don't I just go ahead and add a line chart in here? So I went to my visualizations flyout, add a line chart. And if I want to maybe look at this and further subdivide this by my operators, I can just quickly take this operator, I can drag and drop it, make it by color by here. I get all my different operators. And I can over here add it to the operators here, and now I can quickly see the operators and the wells, and this is all automatically brush linked. I can select this data and see it working automatically brush linked there. Now, new in Spotfire 11 is Spotfire Mods, which is a JavaScript framework that allows you to create plugins to go into your Spotfire analysis. And these plugins can be custom visualizations and custom actions that all use the JavaScript API within Spotfire. So I can see an area chart mod and an animated bubble chart. I can see a spider chart, and I can just go access these from the community. I can download this for free and put this visualization right into Spotfire. So let's go ahead and do that. I've already went ahead and downloaded this spider chart. I have this mod file. All I gotta do is simply drag it and drop it into Spotfire. And here I can see that it's already put this spider chart in. I'm gonna make my X here. I'm gonna go ahead and make this the month of production, my time series production data. And for my Y, I'm going to look at oil produced, and I want to look at this by operator as well. And so now I'm seeing here, let's go ahead and move this map over. I'm seeing how the different operators are producing oil over the year, and I get a profile of each of these I can compare it to. Now, Spotfire Mods is not just custom visualizations. Like I mentioned, it can be actions and animations. It can be custom UI elements. So I'm going to show you that here with the animated bubble chart mod. I'm going to go to this pre-downloaded animated bubble chart, and I'm going to drag this in, and I'm going to show you what a animated visualization can look like. So my x-axis here, I'm going to just make this the producing hours, how many hours let's say each operator has produced, and let's see how much oil they have produced, and we'll size this by oil as well, and we will animate this by let's go ahead and animate this by production time. So I'm going to make this larger so we can take a big preview at this and move this over here. Let's go ahead and get this going a little bit farther in my animation, and I'm going to hit play, and you're able to see here how these operators are moving over time as they produce more oil. You're able to get this temporal view of the data a lot better, and so this is a animated Spotfire mod that can be used. So with that, I think I'm going to hand it to a data scientist on the team, Colin Gray, and see if he can do a little bit of a deeper exploratory analysis.
Now we want to apply some data science and really to augment what we've done before. So to do this, we're going to look at geoanalytics of the well data that we've seen. Here we see we're using Spotfire's AI recommendations on the well data. It's suggesting a map, and it's automatically built us this map showing us all the well locations and what their production is. Now we're going to quickly color that map so that we can see by color and size where the highest producing sites are. And we can zoom in and zoom out and use Spotfire's inbuilt mapping capabilities. But we want to augment this with extra data that we can use to build predictive models. So we've got this porosity and permeability data, and I can simply drag that on to plot that as a new layer on my map. I can drag porosity on now. So it's very easy to build up these multiple data sources to augment your data. And now we can start to analyze geoanalytically and spatially how porosity and permeability relate to productivity of a well. The idea here is we want to build a data science model based upon these attributes to look at where the best well production may be and also understand future well production for the existing ones. But as you can see, while we have these points where we understand permeability and porosity, they aren't exactly at the same points where our well information is. So how can we solve that problem? To achieve this, we're going to use a clustering algorithm. We can download this algorithm from the TIBCO Community Exchange. We can see a whole suite of data functions here available for Spotfire. And the one we're going to use is called the Voronoi polygons. We can click on it, and simply download from the Releases tab. And we can register that into our Spotfire library. So now, using the data function flyout new to Spotfire, we can find items in our library and search for that data function we just added. Here it is. And we simply pin it. That adds it to our favorites, and we can quickly access it now. If you click on that, it will now bring up this nice interface where it describes the data function and what it's going to do. And we can look at whether we want to run this automatically as data changes or not. So here we configure it. We're going to pass in the porosity and permeability geographical data, and that will add that to the data function so it can build clusters. So here we say, use the porosity and permeability to build clusters so that we can geographically relate and mark our wells. There's optional parameters we don't need to fill in, but in this case, we're going to use one called reduction to sort of smooth out the clusters to give us a reasonable size. We hit OK, and that now runs the data function, and it pulls back the results, which is that data containing our new clusters using this algorithm. And it's also built an ID column, which you can get added to a porosity data, which tells each well what cluster it belongs to. So we can see that we've added that as a calculated column to the table. So it's augmented our data set with new data we did not have before. So this is showing you our Voronoi data that's been produced, and we can drag that on and see the clusters it's built. So we're simply dragging on, get a feature, and here we can see all the clusters. If we color them by porosity, we get a feel for the porosity in that cluster. Now we can zoom in, and we can look at what wells and what data points we have sit in what clusters in this area. So if we turn off porosity and permeability, we can see how the blue dots overlay with these new clusters. And we used another data function to geographically mark those with IDs. So with a little bit of cleaning up, this is what we've got. We've got this nice map on the left where we've matched our polygons. And on the right, we've got the total production of each well in the gray bars. But what we've done is use data science again to do some forecasting. Here we've got a model fitted in the blue line, and we've got a black line showing the forecast. So the real strength here is that we can actually highlight clusters on the left, and it will update our forecasts on the right to just match the wells that are in those clusters we generated with our geoanalytics. That's great because we can now go in and pick certain clusters where we see certain patterns of porosity and well production and say, well, if we look at those particular clusters as generated by our geospatial data function, what's the predicted forecast? And we can see that over a time period here of 12 months. But actually, we can run that data function, which is running a Python forecasting algorithm, and we can change how many months from 18 to 12 or whatever's needed. So now we've done this exploratory spatial analysis, augmented our data, and also analyzed forecasting future production. We can now share these data assets we've created and information for wider use across the organization.
Hi there, this is Marc-Andre Dion. I'll spend a few minutes to talk about EBX. So now that you've seen how data can be analyzed and visualized through Spotfire and our data science offering, now I'm going to present how we can manage the data. So EBX is a web-based platform. So whether you're any type of user, you just log in the tool through a web browser. Once you're logged in, you're presented with what's called a perspective. So here I've got different domains like companies. I might have some people information, some employees, and so on and so on. What we're interested today is well data to go with what you've seen previously. So here I'm presented with the well perspective. So I can log in and view the, okay, well, I've got different reference data for the well. I've got well type, shale, operator, and so on. And then I can have a look at a dashboard for my quality of the data. Here I've got how many records are in my table. If there are problems here, I can see there's 2 errors. So maybe I want to go in and have a look at these errors. So I can click on that. I can see that there's 2 records that are in error. I can open up a record and see, well, the error, what's the error? Is the completion date cannot be before the spot date. So I can have a look at here. I can see that the completion date is actually before the spot date. So it's not correct. The other thing is, if I'm looking at well data here, I can open up a record. I can see that a lot of these different values, the attributes for the record are actually dropped down. So because I had my reference data, here I'm forcing the user to go through a drop down instead of free text. That avoids a problem at point of entry. Remove the data quality issues at point of entry. But the other thing that this gives me the opportunity is to view my data in a hierarchical way. So because there's a relationship between, I don't know, the region and the shell and so on, if I close this well, I can say, well, I'd like to see my well by region, for example. So I can just say, well, I want to create a new view. I want to create a hierarchical view, and then EBX will automatically offer me the different relationship that exists in my data. So here I've got shell, but I can see region as well. So if I click on that, I say create and apply. Now I've got my different region, different shell, and then all the wells are associated with that. So it allows me to see the data in a graphical way, and that is easier for me now. Now I can open up a record like that. Now, just quickly, if I want to show, I'm an administrator, so I can open up the records and edit them. But really, a normal use case, I would be logged in as a normal business user. I log out as my admin. I log in as my business user. Again, my user might have different perspective access, but I'm going to go back into the well perspective, look at my wells, and then I can view these different wells. I can say, well, I'd like to have a look at this well. Is there a problem? Now I can see here I'm in read-only mode. However, what we did here was we added a workflow. So if I click on the update button, what happens in the background is it will kick off a workflow. It will create a data space, like a sandbox area for me to see, okay, well, now I've got a full read-write access. I can look at the error, change the date, look at the date. It's actually a typo. It was 2013. When I save that, my error is gone. Now I'm happy with this record. I can say, well, I'm going to send that for approval, change the date, submit for approval, and then it's gone. So what happens is, if you look at the record here, it hasn't changed. What's happened is a notification has been sent to the data steward team for them to come and review the data. So if I log out of my business user and I log in as a data steward, now again, my data steward might have access to other perspective, but we can see that they've got some tasks in their to-do list. I can have a look, see what's happened here. Someone's changed the date. Now it's for anyone in the data steward group to come and look at the record. So I take and start. This will show me the record. I can view the history of the record. So someone's made some change, so they changed the date. And then I can say reject or approve the update as I wish. And in this case, maybe I've got option to change other things. So hopefully this was interesting. And I will hand it to a colleague so they show you data virtualization. Thank you.
Wow, we saw some pretty amazing use cases from Spotfire, geoanalytics to metadata and master data management. Now let's take a step back and let's see how these different layers, analytics, data science, MDM, and any other layer in your organization can be provisioned with the right set of organized data very quickly, efficiently, in real time, and most importantly, in a self-service manner. Here we have the same well data set that we saw in the previous examples, except this data is now coming from multiple different data sources and data silos. This well data is coming from Azure SQL Server Cloud Database. We have a bunch of CSV files that are coming in from Amazon S3 storage. And we have this Spotfire, the geoanalytics data that contains permeability and porosity data that Colin created. This is coming from Spotfire. So we'll see how we can combine these different data sets into a master view and provision it for external applications for use. So let's consider I'm a new user and I don't really understand these data sets as well, and say I don't know the different relationships and how to join them. Well, TDV provides a discovery mechanism behind the scenes that's basically that runs a sampling algorithm on the data sets and traverses through all the data to identify the potential relationships. I've executed the discovery model previously, and let's see what we get as the output. So here we have all the tables and all the potential relationships discovered by our process. I can click on any one of those relationships and I get a detailed breakdown on the different on the scoring factor of the relationship, along with the different weightage factors that contribute towards that. I can see the cardinality if it's one-to-one, one-to-many, and many other different tools available at your disposal. I can crank up my relationship score to 90%. And at this point, I'm pretty sure that these relationships discovered are genuine to my requirement. I can model my data based on these relationships. All right, let me go ahead and create a new view on top of this. I'll just call it production view. And I can start dragging and dropping all my different data sets onto the palette. First, I'll drag in the well data, which is coming from Azure. And I'll drop in my CSV from S3 storage. And as soon as I do that, TDV tells me that this relationship was discovered in the process, and I can go ahead and utilize that. Let me just bring in one more production data along with it and join it with well data. At this point, I have my model ready, and I can go ahead and bring in my different columns. And the view is pretty much all complete. I can go ahead and execute this view, which will give me a sample data combined with Azure, sample data set combined with Azure and S3 right at my fingertips. I can look at the execution plan. I can see how the data is being fetched, how it is joined, what are different join algorithms being used, which gives a lot of power to the end user and the developers to actually model the data. I can go one step further and click on show statistics, which will give me the breakdown on all the different resources and timings that are being utilized in each part of the query, which is also pretty powerful. And again, behind the scenes, there's TIBCO's intelligent optimization engine that evaluates all this workload at runtime, and it dynamically selects the best combination of optimizers, join algorithms, and execution techniques to ensure that we get the highest performance. All right, so at this point, I'll just go ahead and publish this source so that it's available to my end sources. It just takes a couple steps, and I have my view published. I can go into my Spotfire and connect to my data virtualization platform and bring in that data set to analyze. It's as simple as that. And now it doesn't have to be Spotfire. It could be any BI tool like Excel, a SQL Squirrel, Tableau, Power BI, or any other analytics application. All right, let me get back to the TDV Studio. And one neat feature I wanted to show was the lineage. Now, every single object in TDV has a lineage view, which gives me the relationships on which give me a view of the relationships on how the data is actually related to one another. This provides traceability and ensures optimal management of data and platforms. I can just looking at this see that these two data sets are related, and there is a production view being published for external use, which is pretty neat. All right, now I'm going to move on to the data catalog, which is the web part of data virtualization. This is mainly useful for end business users or business analysts. They can come into this platform and they can directly search for the data they need right from data virtualization. So in this case, I search for well and I get all the different well data sets looking at the keyword. Here's my production view, and I can see the summary, the columns, the sample data, and based on this, I can decide if this data set is really something that I need and correct for me. At this, I can also use this web application or data catalog to create my own workflows. So I can, for example, I can combine this production view with the porosity and permeability data, and we will provision this combination to the data science platform in the next step. So let me create a new flow. Click yes. Again, this is a similar concept. Everything is drag and drop. I'll drag a join at this point. and it will automatically take the join from my discovery process. And I can go ahead and publish it right from the web UI. And I can see the different endpoints and the different connection strings available for use. All right, now we have our views published and our data is organized. We are all set to utilize this data in any of the analytics or BI platforms. In the next section, this combined data will be utilized in our data science platform for some advanced machine learning and predictive concepts.
We can now use TIBCO Data Science, which is a web-based platform that works with any size of data. And it's a very collaborative platform where you can see different projects, people who are working on with different roles, and all the workspaces in there. We're going to look at our own workspace, our project, analyzing well production and trying to predict that with the data we've now gathered from our data virtualization and EBX data sources. We can see the data sources and all the work files in this project. The work files can be data, or it can be workflows that are data science drag and drop workflows. So here we have a starter workflow where we've got our data coming from our data virtualization TDV platform. And you can see if we just right click and run it, you can easily view that data. So now we want to build a whole data science lifecycle workflow. And this is a very drag and drop platform. So we can quickly drag on, say, something to filter rows, configure that. So we're going to remove null production values. Simply hit OK, and then run that, and you can see the results. And this is all happening in database. No code involved at all, so we can explore all these different operators and build out the process. Now we want to build in sampling. We want random sampling so we can have a training data set for our model to learn. And then we'll have a test data set that the model hasn't seen, so we can do a proper test of how good quality those models are. Are they really going to predict well production accurately or not? In here, we've got a whole suite of models we can use, and it's again very drag and drop, so no code needed. So we pull on a forest regression, a linear regression, and a gradient boosted trees. We can even pull in and write our own Python or R models, but in this case, I'm just using the built-in ones. Again, configuring all those models is completely codeless and easy and intuitive to do. We can run those models and it then executes them, and you get results out per model, such as the coefficients, the different model parameters, and looking at the residuals. So we've built our models. Now we want to actually predict with our test set. So we connect all our models in, and you can easily do this again in TIBCO Data Science, automatically pulling it through these predictors. And here we see some statistics that help us choose which model's best. So the workflow is good. I want to save it. The team can now see what I've done in that comment. But now we want to take that and really analyze the models in depth. And to do that, we use Hyperconverged analytics because we can connect Spotfire to TIBCO Data Science. So here we see a dashboard that I've built. And how did I do that? Well, I used the TIBCO Team Studio Data function to call the workflow directly and pull the data into Spotfire. You see the same scores from before. We see things like variable importance from models, so we can learn what drives the prediction, what's important, and that can be useful for digital twins and simulations. We see in the middle, what we're seeing is the actual production of each well plotted versus the predicted production by our new models we've built. And we can see the three models here: boosted trees, linear regression, and random forest. And you can analyze the points. You can see the R squared, which is a good measure of how good the model is. And you can see how far the points are from the ideal line shown in green. We've also got analysis of residuals down the bottom. So this gives us a really nice in-depth analysis of all the model predictions from our machine learning and data science models that we produced in our Team Studio workflow previously. We can use Spotfire's brush linking to look at individual points. We can understand good predictions and poorer predictions and really look at what's driving those. Another key benefit is using Spotfire's filtering, which allows us to look at, for instance, different operators of wells, seeing which the models predict better than others, looking at different levels of production. We might want to see whether we need multiple models to give the best prediction for an area, for a level of production operator, or whether one general model like we have here works. One of the greatest benefits of working this way using TIBCO Data Science with Spotfire is we're now able to expose different parameters in that data science process, such as how the models are built and the way they optimize. This allows us to easily tweak and build the very best models we can. So for instance, we can change how this regression works to use a different technique. We can change how in-depth the boosted trees are. And now we can click Update Models. And what it does is it actually passes all those changes back into TIBCO Data Science and reruns the workflow, taking the data from our data virtualization systems and building the models again. That allows us to review and interactively analyze the model results and very quickly use a visual way of driving data science. Now we have a model that is production ready. So what we want to do now is deploy that into a live event stream so that the rest of the business can get the benefit of all this powerful data science work.
Wow, that was some cool stuff from Colin. I'm not a data scientist, but what I can do is put this model into real-time scoring and monitoring. As an operations analyst, my job requires fast insight to prevent issues on the ground and capture new value quickly. Here you can see information flowing into the dashboard in real time through data streams. Streaming analytics is no longer a niche, but it is necessary to respond to critical operations in our business and even help us prevent machine failure like we will see later here. Let me show you how to add streaming data to our analysis. Here's TIBCO Streaming with a full-fledged streaming studio where you can deploy models and create event streams. It has a wide connectivity. We have over 150 connectors like TensorFlow, Apache Kafka, OSI Pi, and more. In TIBCO Streaming Studio, we can drag and drop operators to build workflows on how to treat our data. Here we can clean, enrich, transform, and aggregate our real-time data for consumption. Here we can also deploy and operationalize models with real-time data. We have also recently introduced TIBCO Cloud Data Streams for cloud-based real-time data streams with no code to make it easy for data analysts to leverage real-time data. To create a data stream, we select Create. Here we can connect to Apache Kafka, MQTT, and TIBCO Streaming. We only need to add the name of our bus to connect. TIBCO Cloud Data Streams is able to automatically detect the topics within a bus. We don't need to know the name of the topics like we do in other tools. For the purpose of this demonstration, I'm going to simulate some sensor data with the Fit Simulator to test out our operations. Up next, we continue the configuration of data stream, and we're done. Super quick with zero code. Now we can start our data streams, and we are able to connect to Spotfire. Here in Spotfire, we connect to TIBCO Cloud Data Streams through SSL. Now we select our sensor data stream, and we're ready to start building our real-time analysis. Let me show you how we can discover anomalies in real time. The analytics on the event stream are designed to detect anomalies, leading indicators of equipment issues, for example, supply interruptions, drifting off course. The streaming analytics include deriving features that show signals in the data and applying predictive models that detect anomalies as they occur in the field. Here you see wells on a map on the left, and as a grid showing each well as a square across the top. As the data point turns red, the well goes into alert status. In this view, we can monitor high pressure and low current as they are displayed in red. We can see the sensor traces over time, and we can drill down to particular wells. We can also see a schematic of the well that assists the engineers interpret the alert. Engineers can also keep track of all alerts in a graphical table, and by sorting the table, it keeps the alerts at the top as they occur for fast detection. Lastly, real-time data in Spotfire is immersive. As an operations analyst, I can customize the threshold of my alerts, therefore allowing me to put the algorithm behind a button for fast decision-making. Now we're able to monitor data from the wells in real time and identify exceptions that can be managed to resolution by our fields team.
Well, thanks, Monica. That really was awesome. Hey, Dave, this type of IoT and asset health solution is actually applicable across a number of industry sectors and use cases, right?
Yeah, absolutely. So this approach scales across verticals and industry sectors. This could be applied to, let's say, next best action for campaign modeling in retail, or operational excellence in supply chain, or yield optimization in manufacturing, just to name a few.
No, it's fantastic. Yeah, I really like the way the folks got into the individual data management analytics software components, but also how well they work together across this demo.
That's right. That's right. So as we mentioned before, that is exactly the idea of hyperconverged analytics, the combination of A strong data management layer combined with comprehensive analytic capabilities is what enables organizations to break down data silos and increase trust, and also leverage AI and automate for digital innovation.
Absolutely. You know, and our products have this perpetual goal, as you know, on better together. So our actual engineering effort is not just building the individual products, but it's making the products be loosely coupled, but also tightly integrated, right?
I would have to say that's clearly showcased right here in this demo.
Well, Dave, it's always a pleasure to work with you on this, and our teams collaborating in the field is awesome, and look forward to our next chapter.
Absolutely. Thanks, Michael.
Cheers.